Hi and welcome back. So in the past couple of videos we've been going through this problem where it was kind of a very Algebra 1 like problem where we were talking about that we went out to an apple orchard and a bunch of different people picked apples and we had all these different weights for their apple basket and we were trying to figure out how much was the weight of one apple just based on how much each person picked. And we found out that the weight of one apple in this example was going to be 0.8 pounds. And now I was promising you that this was going to relate to Millikan's oil drop experiment, so I think now is a good time to show you exactly how this relates and exactly what Millikan's oil drop experiment was about. So I'm going to scroll up here and give myself some space. So Millikan's oil drop experiment was all about figuring out the charge on one electron. That's what they were. Oh, there we go. There we go. The Millikan's oil drop was about trying to figure out the charge on one electron. And so let me explain what they were doing. Essentially what the experiment was they had a canister. Let me draw it. So they had a canister that was I think mostly evacuated. That there was a vacuum inside of this canister. Looks something like that. And then they had a viewing piece. Well, actually, you know what? I don't really have to draw the viewing piece, I don't think. The important part is that at one end of this canister, we'll say that this will be this sort of lighter magenta color. They had a plate on the canister. They had a metal plate where they were applying a positive charge. And at the other end, it was actually, they had another compartment, I think, in the top of the canister, which was where oil dropped down from. But this other plate at the top had a negative charge. And essentially what they were doing, let me say, maybe yellow will be the color for our oil. They were essentially taking atomized little drops of oil. So they had like kind of an atomizer spray, sort of like a perfume bottle, that was going to squirt oil into this top chamber, and then it was going to drip down into this bottom chamber. And essentially what they were trying to do was they were able to control what the voltage was on each of these plates. And what they were trying to do was, as one drop of oil came down, and as one drop of oil, and the tiniest little drop that they could possibly get, came down through the hole, what they were trying to do is they were adjusting the charge on each of these plates so that this drop would suspend and would stop moving and stay exactly in between the two plates. And so based on that, and based on how much charge they had to apply, they were able to measure essentially the charge needed to keep this one little drop of oil suspended between the two plates. And so you can imagine, you're probably asking right now, well, what did that have to do with the picking apples example? And this is what it had to do with it. You can imagine in this one tiny little drop of oil, and they tried to get the oil as small as they possibly could, but in this one little drop of oil, they're going to be, and they're going to do this a whole bunch of different times, there are going to be enormous different numbers of electrons in this one little drop of oil. And this is going to be way off, but say the first time there are maybe 1,300,000, I'll just write down some other digits, 3, 7, 6. The other time there are maybe 54 million, and this is even way off. There are way, way more electrons than this. We could even say that this was probably something like times 10 to the 17th. That's how many electrons there were. But the point was that there were enormous variations in the number of electrons that could have possibly been in this one little drop of oil. And the point was that they kept on doing trials of this. They kept on doing as many trials as they possibly could. They did, I think, like several hundred trials to figure out what current would keep this drop of oil. And the drop of oil kept on having these vastly different amounts of electrons that were in each charge. But then they figured that at some point they're going to have, if they tried to figure out what a common denominator was, or what the charge, what the charge was, or the common factor between all of these different charges that they were measuring, they would eventually come down to finding the charge on one electron. And probably I'm probably confusing you with this right now, but hopefully the you can see that this is a little bit like that apple picking example, where we were trying to, let me scroll back over to it. Okay, here we go. So you can see we had a whole bunch of different apple baskets that all weighed different things. And you can think about, like, these are like our different drops of oil. They've got all these different numbers of electrons in them. But we're trying to figure out, well, how much does, we could say, how much does one electron weigh? And we're actually trying to figure out in the Millikan's experiment, what's the charge on one electron. But you can imagine we were trying to figure out how much does one apple weigh, and we only had 4 trials. We only had 4 different baskets in this experiment. Millikan's experiment had hundreds of trials, and they tried to figure out what was this common factor that they all had. That when we multiply, or I should say, not when we multiply, when we divide, when we take the ratio of the charges to all the different factors that we measured, to all the different charges that we measured in our hundreds of trials in this experiment, we are going to get we are going to get whole, we are going to get whole numbers. We're not going to get fractions. We're not going to get, like, if you remember, we found 6.5 to be, or one person picked 6.5 apples when we had our first guess for how much an apple weighed. So we had to figure that an apple weighed half as much as we originally thought. So I imagine I'm probably confusing you with this. So I'll probably have to do another example, and I kind of am realizing right now I'm probably not explaining this very well. So I will try to do some more examples that will hopefully explain this more fully. But the important thing to see is that what we want, when we take the ratio, when we make a guess as to what the charge on one electron actually is, when we take the ratio of that charge of one electron to how many electrons would have been in this little drop of oil. So when we take that ratio of the charge of one electron to how many electrons were in this little drop of oil, and we do that over 100 different trials, that we are eventually going to figure out what the charge is on one electron. And so anyway, I'll just sort of, the last thing I'm going to mention in this video, and I promise I will do more examples on this that'll hopefully show you a bit more about Millikan's oil drop experiment and give you maybe a little bit more intuition, because I don't think I did a very good job explaining exactly Millikan's oil drop experiment. So I'll try to do another video on that. But the final thing I want to say was that the charge that Millikan always found the charge that Millikan always found his measurements to be a multiple of was minus 1.60 times 10 to the minus 19 coulombs. So that is that was what Millikan determined to be the charge of one electron, and this is the charge of one electron, the figure that we will use for maybe some more problems that we'll hit later on in the book. And I promise I'll do some more, maybe one more video explaining Millikan's oil drop experiment that'll maybe clarify this. And please, if you feel like you still don't understand this last explanation, please leave me a comment and I'll try to update this video to hopefully be a little less confusing. So anyway, thanks so much for watching, and I'll see you in a future video.